All right, this is lesson 1-2 in geometry. We'll start off today talking about a segment. Last time was points, lines, and planes. Today is segment, which we kind of all probably have seen before, is part of a line with two endpoints. So it's still a line. It's still got one dimensional, but it's just part of it to where it doesn't go on forever in this direction or that direction. So you notice it doesn't have any arrowheads, right? It actually ends at two different points. This particular segment right here has endpoints of A and B. So how do you name a segment? Well, since they're points, they got to be capital letters, right? And we'll name it by its endpoints, but we won't put the line bar above it. We'll just put what's called the segment bar. You see how it has no arrows on it. Like we'll learn next time that that thing's called a ray. Remember, that is the line. So picky, picky, picky right there. So segment AB. You could also call him segment BA if you wanted to, because those are the two endpoints. It doesn't matter what order they're in. So that's a segment right here. And then here we'll talk today is really about distance. So we can have the distance between 2 points like one-dimensionally, and here's what I mean by that. So like, let's just say we got our friend Yolanda here. She's traveling from Hays to Salina along I-70. She gets off the interstate, or gets onto the interstate, excuse me, at exit 159, right? That's in Hays. And then she drives, and then she exits at 250. What is the distance that she drove? Well, what we can do is, since like the interstate is kind of like a number line, you know, like I don't know if you knew that or not, but every one of the markers out there is for a mile. So it's just like a big fancy number line. The only thing is it's not perfectly straight, but we can just like subtract these guys from each other. So if we took like 250 minus 159, and of course we can definitely use a calculator if we need to do that. So 250 minus 159, what's going on with this calculator? Holy cow. Okay, sorry about that. Had to reload the old calculators on the fritz there. But if we take 250 minus 159, we got ourselves 91. So that just basically means that like she traveled 91 miles in that case. So pretty darn accurate right there. What about like when she comes back though, dude? You know, like if she went the other direction, like should that be like negative 91 miles because she went the other way, or does it not really work that way? Yeah, that's right. It just like, it doesn't work that way because distance has to be positive, right? So even if you took like, you know, the where she left at 250, my bad, at 159 minus 250, you do get negative 91, but mathematically we do a little thing that says we got to make this positive. We're going to put that in absolute value bars right here, if you remember those from algebra. So the absolute value of those two guys minus each other means we're going to be positive, because distance always has to be positive. And the way we write it is, if we wanted to find the distance between any 2 points, is we put the two capital letters next to each other without any symbols above it. We don't have the line bar, we don't have the segment bar. So you can see our notation so far. There's the line bar that says line AB. This is segment AB, and this is said the distance from A to B. And all it really is you're going to be given two values on a number line, right? One of them's x1, the other one's x2. It doesn't really matter which one's which, but all you do is you subtract them from each other, and then you take the absolute value. Absolute value is a grouping symbol, so we got to do what's in there first. So let's dive in. This is the work I want you to show. So they say find this. Most people, if I asked you to say that out loud, they would say BD. I feel you, but now we got to be in geometry. That says the distance from B to D. So we're going to find B. He's at -7. We'll write him down. And then I need to subtract away whatever the other point is. D, it's at -1. So here we go, starting off with our minus situation. And of course, it's all got to be in bars. So the minus a minus, we're going to turn into a plus in that case. And it's -7 plus 1. And right there, that would be a -6, but he's still in the bars. You got to clean what's up in there first. Then you do the absolute value. The absolute value of -6 is a +6. Those are 6 units apart, which most people are like, geez, why did you make me do all that when I could have just counted? Like from B to D, there's 1, 2, 3, 4, 5, 6. Duh. Of course you can do that. But when it comes to like larger numbers back here, I don't want to sit there and make a number line and totally like count from 159 to 250 and count 91 tick marks and all that stuff. That would be ridiculous. But so we're just learning the theory behind it. And yes, again, I do want you to show this work, right? So let's find the distance from D to G. I'm going to do that work right here. I'm going to start with my bar this time. Notice I'm making them taller than my numbers so they don't look like ones. So D is at -1. Then I need to subtract away G, which is at 8 in that case. And yes, you can use a calculator if you need to, but -1 take away 8 is -9. It's still in the bars. And now that you got just one little term in there, you take the absolute value of that and it turns out to be a +9. So the last one of these is find the distance from F to A. Start with a bar. F is at 3. Take away A, which is at -9, so there's a minus, which turns into a plus, and then we get the absolute value of 12, which, welcome back, sorry that my pen didn't work very well right there, with the absolute value of 12, boy, struggle bus, like the computer's been sitting all summer. Absolute value of 12 is 12. Absolute value does not mean change the sign, it means to make it positive, and 12 was already positive. And then we get one of our big words that we'll use a lot if things are congruent, right? The definition of congruent are any figures that are like the same size, same shape. We deal with a lot of congruent things here in geometry. So figures that are the same size, same shape. We'll see a new symbol. We'll get this guy right here. I think we're pretty familiar with. He's the equal sign, but we put a little tilde above it, and that is the congruent symbol. And then how do you mark segments congruent? Because we're talking about segments here in this first little section right here. You use tick marks. And I'll show you what that means here in a second. But we're going to use what we call tick marks, meaning that segments are congruent for each other. So let's just dive in and see what I mean by those tick marks here. All right, so on line AC at the right here, that says the distance from A to B is 3 centimeters. So we're going to learn that we're going to put everything in the picture. I know you might not like it, but it's going to make this so much easier to see what's going on. So the distance from A to B is 3 centimeters, and the distance from B to C is 3 centimeters. Do you see? Distance, distance. So then here's some true or false questions. True or false? Segment AB, this blue guy right here, is congruent to segment BC. Well, congruent means same size, same shape. Well, they're both segments, so booyah, they're the same shape. And they're both 3 centimeters long because segments only have one dimension, so it could be length. So I think that is true. They are congruent to each other. So we'll put a T there for true. We'll probably use a pen instead of a highlighter, but whatever. But it says, if true, mark the picture. So we'll mark them congruent with these tick marks right here. We're going to go to roughly the center of that guy. It doesn't have to be perfect, but boom, boom, we'll mark those tick marks, meaning they are the same. Since I put one tick mark on him, I put the same amount of tick marks on this guy. If I was to have like 1 tick mark and 2 tick marks, those are now different than each other. So the tick marks mean that they are congruent to each other. True or false? The distance from A to B is equal to the distance from B to C. That's true. It's 3 centimeters, 3 centimeters. So that's true. But now I did that on purpose because here's where the symbols get picky, 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 picky. It's just like a fact here. Segments are congruent to each other. Do you see here? They have segment bars above it. And distances are equal. Do you see this was a distance, this was a distance? They use an equal symbol. So like true or false, the distance from A to B is congruent to the distance from B to C. That can't happen because the distance from A to B is 3 and the distance from B to C is 3. Yeah, they're the same, bro, but congruent means the same size, same shape. 3 is not a shape. It's a distance, right? So this is false because it's just bad terminology. It's bad symbols. Like you can't have that. And segments can't be equal to each other either, right? It says segment AB is equal to segment BC. Like I would say most of the world think that that's a true statement, but that's actually false because of the notation just being not quite proper in that one. If you use a segment bar, it has to be a congruent symbol. Segments are congruent and distances are equal. I know, it's picky, picky, picky. And then finally today we'll talk about some two-dimensional distance. What we just did a second ago was one-dimensional because this was your number line stuff. It was just like got one dimension. But here we're on the graph, so it's got two dimensions. It's got an x-axis and a y-axis. It's got like length and width kind of stuff, but no like thickness kind of thing. That's why it's called the coordinate plane. The formula for distance between 2 points, if they are two-dimensional, it's this. They use A and B as generic letters, but that says like the distance from A to B is going to be this old honker of a formula right here. It's way easier than you think. So here's what we'll do. Let's just dive in. It says find the distance between each pair of points. Instead of A and B, they're using point R and point S. So we'll write it like this. The distance from R to S equals. And then we got to put this big old square root symbol around it. And then we'll sub in. R, remember, this is x1, y1, and this is x2, y2. It's probably bringing back some algebra memories of when you like found the slope between 2 points, but it's just, this is the first point, so it's x1, y1. This is the second point, x2, y2. And here's what we do. The first group is just the x's. We're going to take x2 minus, because that's what the formula says right here, x1, which is a minus, so minus a minus becomes a plus. And then that little guy's going to get squared. So I have taken care of this part of the formula right here. We'll clean it up later, right? I know people are like, well, if that's 5, squared 25. Hold on, we'll get there. But let's just then finish our formula. So all this work shown, I do want to see. I will grade you on it. Y2 is 15, and then minus is the guy, and then 3. And it's going to get squared right here. Notice this, the only real weird question people usually have is like, what's that symbol in the middle again? It's on the plus. And by the way, this is on your yellow card. You can find it under the linear section. So now let's clean it up. So we'll bring this down, and then we'll bring this down. And then 3 plus 2 is 5. So we do what's in the parentheses first. So that's 5. And it's going to get squared. Plus 15 minus 3 is 12. And it's going to get squared. And then we clean up even further. So the distance from R to S. We still have to do what's underneath here first. So the square root guy comes along. 5 squared is 25. Remember, it's 5 times 5. 12 squared, if you need to punch that in, you can. You raise it to the second power. But it's 12 times 12, which is 144. And then we still got to add those together. So 25 plus 144. Add those up, and we get 169 in that case, and then we do the square root of that guy. So the square root, if it's been a while, you hit second and then square root on your calculator, or if you have a different calculator, let me know if you need help finding that. Let's see if it comes out nice. Boy, that totally did come out nice, right? That is 13. Now, you may also remember from algebra, like sometimes it's like, don't we need like plus or minus? Not in distance. There's no way that distance is negative, right? So the distance from R to S is 13. And that one came out nice. Not very many of them do, right? So we'll usually leave the radical for an answer, and we'll round to the nearest tenth. We'll see that here in a second. But let's kind of dive in and do that again. So again, I don't care if you put this. A lot of kids like it. X1, Y1. X2, Y2. You don't need to do that if you are cool with it. So the distance from M to N is going to equal big old honker radical. First group is your X's. X2 minus X1 squared plus Y2 minus Y1. So 13 minus a minus right there. So this is a guarantee. I got to see that. I want to see, did you put the numbers in the right place? And do you have the symbols correct? So got to have that. Then when it comes to this next step, I'm going to actually allow, if you can handle it, to do 2 steps at once. I personally think it's kind of slow to keep writing all this down over and over and over again. So like if you can do this, the distance from M to N, I left a little spot there just because, but you got to have the big old honker radical. Here's the 2 steps for 1. 9 minus 1 is 8. It's immediately going to get squared after that, and 8 squared is 64. If you can do those 2 steps at one time, I'm fine with it. Plus 13 plus 2 is 15, and 15 to the second power is 225 in that case. So I think it's cool if you skip this one step in the middle. Now, if you don't like that, then don't do it, right? You're welcome to write that down, but I think it's okay if we skip that. Then we got to show the next step. We got to add the 64 plus the 225 together, and we get the distance from m to n equals the square root of 289. I wrote that down wrong, but it's 289. Let's see if that comes out nice. So second square root of 289, and holy cow, it did come out nice. So the distance from n to n is 17 in that case. But that very rarely is going to happen where they come out nice. If you remember, those guys right there are called perfect squares, right? So when you square root a perfect square, you get a whole number back. If we go to my little cool thing called GeoCraft, which I designed around Minecraft. Really, ChatGPT did this. I was just trying to make these problems more interesting. Very tough map to read, and the map's not perfect because ChatGPT made it and it's got a few flaws in it. But here's our mission right here. It's supposed to be like Minecraft, which I won't lie, I don't know anything about. But it's a world filled with hidden treasures, mysterious landmarks, and dangerous terrain. Long story short is you are trying to get the diamond mine, right? So they're going to have you go on this little quest right here. It says you begin your adventure in Spawn Village. If you look at the legend of the map right here, it tells you where all these guys are located. Your job is to write down the ordered pair of where the place on the map is. In this case, it's Spawn Village. So we'll put that in here, and that's at 3, 6. And it says, how far is it to the diamond mine right here? Diamond mine, if we go to this, is at 16.4. So 16.4. And notice since these are two-dimensional, right, because you got an x value and a y value, we need to use this big old fancy distance formula. So it doesn't matter which point's x1 or x2, but we're going to do this. The distance from A to B, I'm just going to cut that part off. I'm going to have the big old square root symbol. And the x's, 16 minus 3, that's going to get squared. And here's the question that a lot of people ask, like, what would happen if we got those out of order? What if, like, we had 3 minus 16? It doesn't matter if they're out of order, because when you square it, it's going to turn it into a positive number. So, like, 16 minus 3 is 13. When you square it, you get 169. 3 minus 16 is negative 13. When you square it, you're going to get 169. So the cool thing about this squaring thing is it doesn't matter what order those two are in. They just are both the x values. And over here, these are both the y values, which it doesn't actually matter which order those are in. So I'm going to do 6 minus 4, but it's got to get squared. Then I'll bring down my big old radical. Again, like I said, this was 13 squared, so that's 169. Again, you can punch that in your calculator, guys. And then plus 6 minus 4 is 2. 2 is going to get squared. That's going to be 4. So when I add those together, that would be the square root of 173. And that, according to my best memories, isn't going to come out very pretty. Nasty little decimal. We will leave the square root of 163. He's called our exact answer. And then we'll put our approximate answer of about 13.2. We're rounding to 1 decimal place. And if you remember, to round to 1 decimal place, you got to look to the second decimal place to see if he's 5 or larger. So about 13.2. And then let's do that again. A messenger must deliver supplies from Harbor Town. Let's find Harbor Town on the map. That's 4-2. And then Crystal Lake is at 11-10. And they ask, what is the shortest distance between those two? Well, it's going to be that straight line that we go across, so let's roll with it. The x's, I'm going to do 11 minus 4, quantity squared, plus the y's minus each other, 10 minus 2 quantity squared, and then I'm going to get myself 11 minus 4, just double checking, 11 minus 4, pretty sure it's 7. Yep. Then you got to square that, so that's going to be 49, plus 8 squared is 64, and then we add those puppies up, 49 plus 64, 113, but he's got the radical around it. And then we'll punch that in. That's not going to come out nice because 113 is not a perfect square. So about 10.6. is how far those guys are apart. So that's the distance between 2 points in my made-up little game from Minecraft called GeoCraft. Like, you'll notice, like, I think the homework's going to ask you about Lava Mountain, and this says Lava Peak. That's what I mean about it's not perfect and stuff like that. So just please use your best guesstimate of which point on the map they're talking about, because ChatGPT makes a lot of mistakes, guys. So, all right, let us know if you have any questions. Have a good one.